Hello, this is Professor Lawrence Orihuela of CSE2000Q2S Computer Science 2, and this is the video showing you how to do all of the problems of the practice final. Without any further ado, let's get started. So, over here is the tentative schedule. If you're watching this video the day it's posted, you'll see that it's November 20th today, and I'm kind of deviating from the original tentative schedule. You see, we were supposed to have the second lecture video for searching and sorting, and I wasn't planning on posting the video for the practice final solutions until December 4th. But here's the thing, I thought about it for a while, and I realized that many students have already completed every assignment for this class. And at this point in time, you're just waiting for the final to be distributed. So I didn't feel like it was worth it to wait 2 weeks for no reason. So I decided to switch this and this around so that today on November 20th, you'll be seeing the video for the practice final solutions. And then on December 4th, I'm going to post the second video on searching and sorting. But the truth is, you only need to see the first video on searching and sorting to turn in activity 10. And you actually don't need to... There's actually no activity for the second searching and sorting video. And that's kind of the reason why I decided to switch it up. So that for those of the students that already completed every assignment, you're not like sitting around waiting for the final. But anyways, aside from that, you have one assignment due tonight, and that's your lab 3. So in case you haven't turned in lab 3 already, there is a video on Blackboard showing how to assemble it. Please watch it after you complete the lecture activity 6 through 8, which, to be honest, most of you already did. And please get it to me by midnight tonight. But if you don't get it to me by midnight tonight, turn it in anyways, because I've made an announcement before that I will accept late work for reduced credits. So yes, please turn in all the assignments to me, because for every assignment for this class, there is a video showing how to do it. So yeah, please turn it in to me so that I can grade it and you can pass this class. Okay, so one other reminder is that, well, even though I'm showing the video for the practice final solutions early, because of my schedule, I still wouldn't be able to have this Zoom meeting until December 4th. So even though I'm giving you the final, like the real final on Blackboard and the practice final solutions on Blackboard right now, I still wouldn't be able to have this Zoom meeting until December 4th, because that's how I originally planned it. But I will be honest with you, this final is so easy that many of you might not even need this Zoom meeting, because the way that I worded this, the practice final and the real final, it kind of just does itself, you know? But if you want, you can attend this Zoom meeting anyways, if you just want to come in and say hi. But anyways, that's all I have in terms of announcements. Anyways, it's time for us to look at the practice final, and I will show it to you, and you will know how to do it as well as the actual final. So let me open this. And let me open this. So over here on the left is the practice final. Over here on the right is the real final, which I will post on Blackboard momentarily. But the reason why I have both of them here is because I want to show you how similar they are. Because look at it. The exam will consist of one program. The exam will consist of one program. Just not even read it, just scan through these questions. They're almost exactly the same. So this video is going to be your best friend when you're actually taking the time to answer the real final, because again, they're almost exactly the same. So if you know how to do this, you will know how to do this very easily. So now keep that in mind. Like, don't try to like get help online and try to like BS your actual final, because if you try to post some like these questions on Chegg and try to get answers for it, I guarantee you that the answer will be wrong. So yeah, don't bother trying to get outside help. Rely solely on this video for answering the questions of the actual final, and if you do that, you will get a perfect score on the final because of how easy it is. So anyways, I will minimize this right now. Yeah, let's get started answering these questions, okay? The first step, I suppose, is opening Visual Studio, because we need to write one program, right? Okay. Let's create a new project. Okay. Empty C++ project. I'll save this. Yeah, I guess this folder's fine. And I guess I'll just name this practice final solutions. Like that. Go to source files, hover over add, click new item, say main.cpp, like that. Okay, so I think I'm going to dock this over here and have this over here so that we can look at both at the same time. Okay. And once you see me do these questions, you'll realize how easy all of this is. So, question 1, making a class. Use the following steps to create a new class called circletype. Okay? Create a header file called circletype.h to hold the circletype class. Include IOStream and using namespace standard. Okay. So I'm going to go over here to source files. Add new item. Select header file. And call it circletype.h. Add. Okay, so over here is my circletype.h. It has this pragma once here. Leave that there, okay? So we need to include IOStream and then using namespace standard. So let's make this bigger so you can see it. Perfect. So up top, say include IOStream and using namespace standard. Like that. So that's part 1 done. Alright, part 2. Circle requires 2 member variables called color and radius. So do the following. Make a section called private. In private, declare color, string and color and double radius. Make a section called public. In public, declare setter and getter functions for both color and radius. Okay, so we need to declare a class here, okay? So say class, and we're going to call it circletype, right? Like that. And I always do camel case where the first letter of the first word is lowercase, but the first letter of the remaining words are uppercase. And then we need to declare two sections. Make a section called private. In private, declare string color and double radius. So we need two sections, public and private. Like that. Under public, we need to declare string color and double radius. That's easy. String color and double radius. Like that. And then make a section called public. In public, declare setter and getter functions for both color and radius. And then write their respective definitions. Now, you already know how to write setter and getter functions from lecture activity 6. And it's very easy. Let's do it here on public. I'm going to put a comment and say setter functions. Now, setter functions are always void. And they accept one data that's of the same type of the private member in which they're setting. So we're going to say void. Let's make the setter function for color. So set color. And because color is a string, it needs to accept a string. So I'm going to put string inside the open parentheses. That's the prototype. Now let's write the setter function for radius as well. Void set radius. And because radius is double, we're going to accept a double. Like that. Now we need to write the getter functions. Now, getter functions don't accept variables, but they do return the same data type as the member that they're getting. So for the getter function for color, we're going to say string get color, like that. And then we're going to say double get radius. Like that. Okay, so now we just need to write their respective definitions in the same fashion we did in lecture activity 6. So over here we wrote the function prototypes. Now it's time to write the definitions. So I will copy this, go down here. Let's get rid of this comment, get rid of this comment. Now, when it comes to member variables, member functions that are members of a class, we need to have the name of the class and then the scope resolution operator following each one. So I'm going to say circle type colon like that. Put that over here as well, here as well, here as well. Delete these semicolons. And add squiggly brackets. Like this. And as for the setter functions, the variables need names. So for this string, let's call the string that it accepts S. And for this double, let's call the double that accepts D. And then the setter functions, as you already know, they set whatever we receive to color. So we're going to say color equals S, like that. And as for the setter function for radius, we're going to say radius equals D. So it accepts S, it sets color to S, it accepts D, it sets radius to D. Okay? Now for the getter functions for color and radius, they're even more simpler. All we have to do is return the private member in which they're getting. So I'm going to say return color and return radius. Perfect. So everything I did so far is shown here. And we completed this part, and which means we completed this part, this entire question. Okay? So let me save this. Now it's time to tackle question 2, which is making member functions. And it says, add the following 2 additional member functions under public. Create a getter function of type double named getArea that accepts no parameters. It will return a double equal to the area of the sphere. Okay? So this is another getter function, even though there's no private member pertaining to it. Because we don't need to calculate, we don't need to save area, we can calculate it. So under here, under getter functions, let's say double and get area, semicolon. Now, it's always a good idea to have the function prototypes in the same order as the definitions underneath. So I will copy this, scroll down, put it over here, get the circle type : put that here, get rid of the semicolon, add squiggly brackets, and now it must return a double equal to the area of the sphere. And the area of a sphere is 4 pi r squared. I can even prove it to you if I open Google real fast. Area of a Wait a second. My bad. This was supposed to say circle, huh? Yeah. Yeah. Area of a circle is Oh, I made a mistake when I was creating this practice final. So I accidentally gave you the formula for the area of a sphere when it should actually be circles. So instead of 4 pi r squared, it should be just pi r squared. My bad. Yeah, sorry about that. So let me get rid of that. So yeah, the area of a circle is pi r squared. So what we need to do here is say we would say something like double area. This needs to be equal to pi r squared. So for pi, I guess I'll just put 3.14. And it needs to be multiplied by radius squared. So I'm going to say times radius times radius semicolon. And then I'll say return area semicolon. Like that. So this is the getArea function. So we can cross that off. And now we need to create a function of type void named print that accepts no parameters. It will output color and radius in the following fashion. Cout color, color, and L. Cout radius, radius, and L. So scroll back to the top over here. I guess put a comment that says print function. And say void print, open close parentheses, semicolon. Copy this, scroll down. We need circle type : in front of it again. Get rid of the semicolon, add squiggly brackets, and then we need to cout color, color, and L, cout radius, radius, and L. So in this fashion, say cout in quotes color, color and line, cout radius. Oh, there should be a space here. Radius and line, like that. And that's it for the print function. So this was knocked out as well. So we completed question 2. So now it's time to move on to question 3. Add 2 constructors under public. 1, add a default constructor that accepts no parameters that will initialize members' color and radius when they aren't initialized by the program. We must set color to white and radius to 0. Again, that's very easy. We already know how to make constructors from lecture video 7, right? So, go down here. Let's add a comment that says default constructor. And call it circletype. Now, because it accepts no parameters, there is no variables inside of this open close parentheses, right? So now we need to take this, scroll down, go down here, put circletype colon and colon in front of it again to indicate that it's a member of the class. Get rid of the semicolon, add squiggly brackets. Now we need to set this default constructor will be invoked when it's not the program doesn't initialize circletype by itself. So we need to set color to white and radius to 0. So we're going to say color equals white. Oops. And radius equal to 0. Like that. And that's it for the default constructor. So let's cross this off. Now we need to add a parameter constructor that accepts a string s and a double d that will initialize members' color and radius when they are initialized by the program. So scroll back to the top. I guess add another comment that says parameter constructor. And we're going to say circletype again. This time we need to have it accept a string s and a double d. So we're going to say string. As always, the function prototypes don't need variable names, so I'll just leave it at string and double. Like that. Copy this, scroll to the bottom, add it there, say circletype colon colon in front of it. Well, if I can, like that. Get rid of the semicolon, add squiggly brackets. Now we need to give them names because this is the definition. So let's call the string s and let's call the double d. And we will set color equal to s and radius equal to d. Like that. And that's it. So we can cross this off as well. Now, question 4 might be the hardest because we're making an inheriting class, but it's actually not that hard. So, if you follow these questions exactly, these instructions exactly, you should be able to get it just fine. So, yeah. Question 4, making an inheriting class. Now create a class called spheretype that inherits from circletype. Okay. So what we need to do is go back to circletype.h and change the keyword private to protected. Now this is very important. That's this part here. In my circletype class, you see this private keyword. This is very important because if you don't do this when you're doing the real final, you're going to run into errors. So this keyword private, change it to protected. Like that, okay? Now, always remember to do this. If you're making an inheriting class, the base class needs to be changed from private to protected. Always. Okay? So, that's this part done. Alright, part 2. Create a new header file called spheretype.h to hold the spheretype class. Include iostream, circletype.h, and using namespace standard. Okay? So go over here, source files, add, new item. We'll add a new header file called spheretype, which is going to inherit from circletype. Okay? Spheretype. Add. Here's our spheretype header file. See this pragma once? Leave that there, okay? But we need to include iostream. We need to include spheretype.h. Include spheretype. And we need to add using namespace standard. So using namespace standard. Like that. Awesome. So part 2 is out of the way. So now have spheretype publicly inherit from circletype by setting the member access specifier to public. Very easy. So this is a new class, right? It's going to be called spheretype. We need to set the member access specifier to public. So say the word public. And this class here is going to inherit circletype. Like that. Oh, my bad. This should be circle, not sphere. There we go. Like that. Okay, so that's that portion out of the way. Now, as always, classes contain 2 sections, one called public and one called private. So let's just add them right now. And then private. Like that. See? Now, sphere inherits color and radius and does not need any more private variables. Therefore, private should hold no members. Okay? So private here is not going to contain any members. Okay? So because sphere type is inheriting circle type, everything in here is like copy and pasted behind the scenes and added to sphere type. Okay? Now, because a circle has color and radius, and a sphere has color and radius, there's no need to add new like private variables, right? So anyways, let's cross this out as well. But we do need to add 3 new members under public. Okay, so so part A says create a function of type void named print that accepts no parameters. Use the scope resolution operator to call the print function from circle type. Okay. So go over here and let's say void print. Like that. Copy this, put it down here, and put sphere type : in front of it. Like that. Delete the semicolon, add squiggly brackets like that. Now, use the scope resolution operator to call the print function from circle type. So the way we do that is we declare the circle type class like this. : and call its print function by saying print. Now, as you already learned from the previous lecture video, by saying this, we are calling the print function of the circle type class. So having this here is the same as having this code in its place. And that's one of the magics of inheriting, right? We don't need to write code over and over again, right? So that's it for this. Next, we will create a function of type double called getVolume that accepts no parameters. It will return a double equal to the volume of the sphere. Okay. So under public, we will write a function that returns a double called getVolume, like that. Copy this, put it on the bottom. Delete the semicolon, add squiggly brackets, add sphere type colon in front of it, like this. Now, we need to make a double called volume, which is equal to 4/3 pi r cubed. And in case you want to double check this, this is the formula for the volume of a sphere. Let me double check that real quick. Yeah, 4/3 pi r squared. Yep. So I guess we will declare a double called volume, which is going to be equal to 4/3 times pi, which is, I'm going to say 3.14, and then r cubed. So I'm going to multiply this by radius 3 times. Now you might notice that private here doesn't have a member called radius. That's fine because the radius variable was inherited from circletype, right? So I don't need to declare radius again. So remember that, okay? So I can say radius times radius times radius, semicolon, okay? And that's what it looks like here. And then I will say return volume. And that's my getVolume function. So save that. Let's make this big again. Yeah, so that's part B out of the way. Part C says create a function of type double called getSurfaceArea that accepts no parameters. It will return a double equal to the surface area of the sphere. And once again, I gave you the formula for the surface area of a sphere. We can double check it if we need to. Oops. Did not mean to do that. My bad. Everything's going wrong right now. Surface area of a sphere. Four pi r squared. Yep, that's correct. I'll put this here. I don't know why it keeps doing that. Anyways, so under public, say double get surface area. Copy this, go to the bottom, put it here, delete the semicolon, put sphere type colon in front of it, squiggly brackets. So let's make a new double called surface area. This will be equal to 4 times pi, which I'm going to say 3.14, times radius times radius. Like that. And then I will return surface area like that. And that's it for my get surface area function. So I will cross this out. The last thing to do is to add two constructors under public. One, create a default constructor for sphere type. Have it called the default constructor of circle type. So over here under public, I guess put a comment that says default constructor and say sphere type. Open close parentheses because it accepts no parameters. Copy this, go to the bottom, put here, we need to put sphere type : in front of it, as always. Delete the semicolon, add squiggly brackets, and have it called the default constructor for circle type. So, you already know how to call constructors from base classes, right? All you have to do is go here to the definition, add a single colon, and call the default constructor for circle type. So just say circle type, open close parentheses, just like that. And that's it. So, as you already know, by having this here, this calls the default constructor of circle type. And this default constructor of circle type looks like this. So, by having this here, that's the same thing as having these two lines of code in here. Right? Anyways, so that's the default constructor. We can cross that out. And now we need to create a parameter constructor for sphere type that accepts parameters string s and double d. Have it called the parameter constructor of circle type. Okay? So scroll back to the top. Say parameter constructor. Say sphere type again. Now it accepts a string and a double, so we need to specify that. Like that. Copy this. Copy this. Go down here. Delete the semicolon, add squiggly brackets. Put sphere type : in front of it. And we need to give the variables names. So call the string s and call the double d. And have it, so that's this part here, have it call the parameter constructor of circle type. Okay. So you already know how to do it. We'll say circle type. And to call the parameter constructor, we need to pass a string s and a double d. But because the data type is already specified in this constructor, we don't need to say them again. We just need to say s and d. So s, d. Just like that. And that's it. So by having that here, if I can show it to you better. So by having this here, you can see that inside the squiggly brackets there's nothing there, but that's okay because this is calling the default constructor of circle type. So by having this here, that's the same as having these lines of code inside of here, but we need to pass the variables s and d to it. That's why we have s and d in here. Okay? And that's it for that. Okay. Lastly, question 5, using both circle and sphere type classes. Now circle type and sphere type are ready to use. in your main.cpp, copy and paste the following code. Take a screenshot of the program running. So see this code here? This is going to be added to your main.cpp. So copy all of this and put it here. Okay? Like that. And save everything. Now, before we actually run this, let's take a brief moment to see everything. So I guess I'll dock sphere type, circle type over here. So here's our circle type class. You can pause it whenever you need to if you want to see everything. To be honest, it was really easy to write this. Well, I hope it is, right? Here's the sphere type.h. As you can see, there's really not that much written because all the other code is inherited. But yeah, the way that I modeled the practice final and the real final is that I got the idea from going off of one of the previous lessons, in inheritance, if I can actually find it. So I said before that I would so because classes are one of the biggest things of C++ that you need to learn, I took this from this diagram that I wrote here. So we have a circle type that sphere type inherits, and then as for your actual final, you have a rectangle type that's cube type inherits, or well, I can't remember what I named it in the actual final, but yeah, this is what you would do if you were actually writing a game engine or a physics engine that deals with different shapes. But yeah, as we can see, we don't see any errors in here right now. So I would think that if we ran this, it would work fine. Let's see. Okay, so this is proof that this program works. Okay. Now, now that let's go back here. So we've eliminated this as well. So yeah, so this, we just covered every question of the practice final. Okay. Now, I think it would be worthwhile if we took time to put the practice final and the real final side by side so you can see subtle differences. But to be honest, they're almost exactly the same. So let's make this a little bigger. So let me uncross out everything. Perfect. So let's compare the two side by side, because I don't quite remember what I wrote in here. So so here is the real final. Question 1 says, making class, use the following step to make a new class called rectangle type. So this is the exact same thing as this, but instead of circle and sphere, I have rectangle and brick. So one is a 2D shape. The inheriting class is a 3D shape, 2D shape, 3D shape, right? So as you can see, there's really not that many differences between the practice final and the real final. There's subtle differences, but aside from that, there's not really. So all you have to do is follow these instructions verbatim, and you will get a perfect score on the real final. So create a header file called circle type. Create a header file called rectangle type. 2 member variables, 3 member variables. Get area is slightly different. Instead of pi r squared, it's length times width. Length and width being private members. And then the print function will be color, length, width. And the constructors are almost the same. Now, the only thing that you might have problems with is question 4. You may or may not. Well, actually, I'm pretty sure you can get it to work because there's really not that much different. But if you can't get it to work, don't worry too much about it because remember, I dropped your worst question, right? Yeah, there's 5 questions in the real final. 1, 2, 3, 4, 5, and I dropped your worst question. But if you can get it to work, that's an automatic. If you can get a screenshot working, I would say that that's an automatic A for your final. So, the inheriting class. So, question 4 is the one with the most differences. Let's look at it and see. So, step 1 is the same for both. This is almost the same as this. Step 2 is the same for both. Step 3 is the same for both. I'm just thinking about when I actually distribute this final, I'm just thinking about what kind of parts that you guys might like trip up on, but I don't see any right off the bat. Okay, so I guess here's one difference for step 4. Sphere inherits color and radius and doesn't need any more private variables. But as for brick type needs members color, length, width, and height because color, length, and width are inherited. You don't need to declare color, length, and width again, but you should, under private, declare a new variable called height, and then under public, declare setter and getter functions for height. I made these instructions very descriptive, so. And then as for that, step 5 is make new member functions. The print function's almost the same. Get volume is easy. Get surface area is easy. And then as for the default constructors. So, yeah, for part 6 here, after you call the default constructor for rectangle type, because there's a new variable called height, you should set height to 0. And as for the parameter constructor, have it accept string s double d1 double d2 double d3. Pass s d1 d2 to the parameter constructor of the base class, and then set height equal to d3. But aside from that, that's kind of it. There's not that many differences. So, anyways, I'm going to go ahead and post this video and your actual final on Blackboard. And you have, let me see. You have until now until December 11th to turn it in. That's a lot of time. So if you're encountering any difficulty dealing with this final exam, well, I suppose it's not a final exam, it's a final project. But if you have any difficulty with the actual final, you can email me and tell me your issues and we will work on it. But my hope is that you will think that this take-home final is very, very easy. Okay? So, I guess the last thing I need to show you is the extra credit questions down here. So, as I said before, in the midterm exam, there was one extra credit question that was worth 10 points. Which is an entire letter grade. I was very surprised then when I saw that not that many students did it, because a letter grade is a lot. And here for the actual final, you have 3 extra credit questions worth 5 points each. So if you do all of them, that's a total of 15 extra points, which is a letter grade and a half. So you have that going for you too. And in order to do these extra credit questions, you already know there's instructions on how to do these too. In at least 5 sentences, explain why it's important to make certain class members public or private. And I actually told you the video that you have to go to and the timestamp you need to go to in order to get the answer for this question. As for this, in at least 5 sentences, explain what inheritance is for classes and why it saves time and work writing C++ programs. Go to lecture video 8 and watch from this timestamp to this timestamp. And then lastly, explain what operator overloading is and why it's needed. And then list 5 C++ operators that cannot be overloaded. Here's the hint. Go to lecture video 9 and watch from here to here and here to here. Okay? So, yeah, this is your final exam. And I will be posting this on Blackboard momentarily. And you will have a very long time in order to get this into me. But aside from that, there's only one video left to post, and that's the second half of searching and sorting. And that will be it. So, thank you for sticking with me for this long for this class. It's been quite a ride. If I were ever to teach this class again, there's like subtle changes I would make. Like this class was a whole learning experience for me. Like if I were to do this class again, maybe I keep it to 3 labs, not 4. Maybe I would have searching and sorting be 1 week instead of 2. Maybe I'd have operator overloading be 2 weeks instead of 1. But yeah, that's kind of it for this class. We're almost at the end of the semester, so make sure you watch this video when you're doing the actual take-home final, and I will post this on Blackboard, and after that, that's it. So I will see you guys later.